All right. So this is your DSXi docking station right here. So taking a look at the back at your connections, you have your Ethernet connection, you have your power connections, and then you also will have your gas cylinder connections, along with your fresh air port on the first connection down here. The fresh air port, this should only have either this filter right here on it or a bottle of zero grade air if you do have a extremely dirty environment where you cannot utilize just the fresh air filter. Biggest thing to note back here is with your tubing is making sure that your tubing and your card reader assemble cables are all going to the same ports. So port number 2 right here is what I'm utilizing, and tubing goes on port number 2. If you have separate bottles of gas, say you have HCN or like SO2 or something that is not in your mix bottle, you then would have that hooked up to either port 3, or if you have the 6-port model, you would have it connected up here through ports number 4 through 6. And again, just making sure that the tubing and the card reader cable for each bottle is on the same exact port, because if you have this on this different port than the tubing, what will end up happening is it will suck air from the wrong tubing connection trying to get gas. You also have your power cable right here, and then we also have these USB plugins down here at the bottom. The USB plugins are not utilized by your docking station mode, so you don't need to worry about them. All right. That background. And let's take a look at the gas bottle and its connections. So on the gas bottle itself, we will have our card reader right here. And as you can see, it's got a little green light. And then we have up at the top, we have our regulator. Okay, now with the regulator, on the side of the regulator, it has this pressure switch. Okay, and with that pressure switch, it's connected into the side of the card reader. Okay, now when you're connecting up the gas bottles, there is actually a way that you need to do this. So I'm going to disconnect all this and show you how that goes, because you have to connect it in a certain way, or else the docking station will think that you've connected up an empty bottle of gas. So I have my regulator, I've got my card reader, and I've got my bottle of gas. Now with the bottle of gas, it has this little card on there. The card has this little gold chip, which gives it all the information that is on the bottle's label. So it has the concentrations, what gases it is, the expiration, the lot number, everything. Okay, that's all programmed onto the chip itself. So what we have to do is, when you connect up a bottle, you need to take a look at your assembly down here, making sure that we have our card reader and this pressure switch is plugged into the side of the card reader. Okay. Now, the bottle has to register pressure on the switch before you hook up the card. So what you have to actually do is you have to thread the bottle on, and it's just a standard righty-tighty, lefty-loosey on these smaller bottles. Okay, I've got that all connected up, and if we take a look right there, we can see I've got pressure on there. Now this isn't a full bottle, but that's fine because it's still registering pressure. Now what I have to do is I have to connect up the card reader. Now to do the card reader, one thing that you'll notice is, and I pointed this out earlier, even without the card in there, it's got a green light. That's because the green light just indicates that there is power going to the card reader. That's it. That's all it's indicating. It does not say that it's reading the card. It does not mean that it's reading the card successfully, anything like that. All it's saying is there's power to the card reader. So don't trust that little green light to tell you that, oh, everything's good. So to hook this up, what you'll see, let's see if I can get this on camera, is right here, there's a little slot. Okay, so here's the front of the card reader. There's this little slot, and then there's these prongs. Okay, right here. So these prongs actually end up going into the slot right here on this plastic collar but the card has to be in front of that. So what happens is this. You take the card and the card reader. I slide the credit card style thing into the reader itself, and those prongs snap up behind the card. Let's see if I can get that right here. Okay. Once they snap up in, okay, on the docking station screen, let me bring that up for you here. Hang on 1 second as I move you around on the little tripod. Okay. Okay. On the screen, whenever I get this connected, it will go from a green light to a yellow light. So that's where I just disconnected it. It says reading settings, and that's because it's reading that, the gas has been disconnected. Now, whenever I actually hook this up, it's going to come up, and on there it's going to say reading settings again. And that's because it's going through and it's saying, oh, okay, here we go. We're reading the settings. We're checking to see what's going on. And now it's registered the bottle's on there. Okay. With the docking station, what you're always waiting for is you're waiting for a green light. You've got green, yellow, and red. So it's just like driving a car. Green means go. It means everything's ready to go. In this case, I don't actually have an instrument inside the docking station. So at this point, it's not doing anything to an instrument. All right. So it's saying, hey, I'm ready and I'm waiting to accept an instrument. Yellow light means slow down. I'm doing something. Whether it's running through diagnostics, it's doing the settings of a new gas bottle, or if it's doing calibration or bump testing. And then finally down at the bottom is a red light. Red light means, uh-oh, something went wrong. Okay. So with that red light, it's very simple. What we do is we just stop, we wait, and we take a look at the error message that comes across on the screen. A lot of times it's something very simple that can be fixed. Like it'll end up saying like out of gas, so that's because the bottle ran out during the test. Or if it's a failed calibration, what I would always recommend to do at that point is pull the instrument out, turn it on, and take a look at what sensors failed. So, looking at your instruments, it looks like the sensor configuration that you have is you do have the LEL, HCN, O2, H2S, and CO. Okay. So a lot of times, if you get a calibration failure that has the LEL, H2S, and CO failed, but HCN and O2 passed, what that's going to tell you is, okay, the bottle that has the CO, the H2S, and the LEL in it, your mixed bottle, something's not connected right. All right, because of the fact that that's a gas delivery issue. Whenever 3 of those sensors that all come from the same bottle don't pass. Now, again, if you get it where all those ones fail and the HCN fails, but O2 passes, I would check all your gas connections then on the back and make sure that they're actually connected properly, because then it's showing me that it probably was sucking the wrong gas whenever it should have been sucking the other gas. As long as O2 passes, what that usually tells me is during a calibration that we've got an issue of gas delivery, because it uses that fresh air port on the back to do that calibration of the O2. Now, you might be saying, well, wait a second, I looked at that bottle, and that mixed bottle has O2 in it. And you're absolutely correct, it does. If we actually take a look right here, here's our gas composition of a mixed bottle. And focus. I think it's focused. I can't really tell. Looks like it is on my side. But what you'll see right here is you have oxygen, and it says 18%. Okay? Now, that 18% is not used for calibration. That's used for bump testing. Okay? Because a bump test is different than a calibration. Calibrations should be done once a month. And the docking stations will just automatically tell it to do it once a month whenever it's needed. And that's due to accuracy of the instruments. Bump testing, okay, is a little different. Bump testing should be done before each day's use, okay? And what that's doing is that's just telling us, hey, the instrument is responding to gas, the alarms are working, It's just a functionality test. That's all it is. It's not accuracy. And this is where some people say, well, should we calibrate every day so that's more accurate? No, not really. It doesn't work that way. What you end up doing then at that point is you're overexposing the sensors to gas, and you're just going to cause them to burn out faster than they need to. I'm a volunteer firefighter here in Pennsylvania where I live, and we have the same exact setup. But we don't have guys on shift or anything like that because we're volunteers. We have people that show up to the station, at minimum about once a week, unless we have other calls, just to do the normal checks. So what we do is we calibrate our instruments once a month. We bump test them weekly. And then inside the trucks on the dog box, we have the instrument sitting in a charger. And then whenever we're going to a call that we need the gas detector, we have a small bottle of gas that we just keep in the officer's seat. And the officer will turn the instrument on the way to the call and just turn the gas on and verify that all the alarms go off, so audible, visual, and vibrating, and that all the sensors respond, because that's all you're looking for. A bump test does not necessarily have to be done on a docking station. It can be done manually. So that's just something to remember with all that.
Now, we have 2 bottles of gas. So how would you go about bump testing that?
Yeah, because you have the HCN as well. So you can do that. You can get, the small bottle of just the mixed gases, and then the HCN, you could just have another bottle of that. The problem with that, though, is HCN is expensive. It really is. So for your setup, I probably wouldn't recommend doing something like that. Are you guys, you have somebody basically on shift 24/7, correct?
Correct. Yep.
So for a lot of professional departments such as yourself, what I always recommend is just once a shift, okay, or once a day. So whoever's on first shift in the morning, when they come in and they're doing their check over of the truck and everything else, just have them grab the instrument, throw it on the dock, have it run through and do a bump test, throw it back on there, because technically a bump test is good for 24 hours. Now, if they go on a call where they use the instrument, when they come back, I would recommend docking it again, just in case somebody dropped it or something happened where, now something's messed up with the instrument, so that it runs through another bump test just to verify that everything's still good. But that's just a recommendation on my side. You guys can come up with your own policies on that. But that's kind of what I've worked with other departments on doing in situations like yours. Mine's a little different, as I said, because we're volunteers and we're not always there.
So just a bump test, and we just put it in the docking station, go through the settings, or does it do it automatically?
So it will do a bump test automatically once a day, okay? But I'll show you here in a little bit. As soon as we go over the instrument itself, I was going to show you the software real fast that you guys have. And I could show you in there where you can actually program it to do a bump test every, 6 hours, 8 hours, 12 hours, however you want to do it. Or you can even set it up to just do a bump test every single time you throw it into the docking station too.
Okay.
So, all right. So, going back to the docking station here, get off that bottle. Let me re-extend my tripod, my desk here. There we go. All right. So, to dock the instrument, as we talked about earlier, what you're going to do is you're just going to lift up on this little cone right here, take the instrument, set it in face down, close that little cone. And down at the bottom, you'll see that my yellow light came on, and it says Discovering on the docking station screen. And the reason for that, what it's now doing is it's reading the instrument, and at that point, it's going to go through and it's going to see what it needs, if it needs a calibration, if it needs a bump test, diagnostics done, record keeping, anything like that. Now, you'll notice that I have a charger down here on my floor next to my desk, and I pulled it right out of the charger and I threw it right into the docking station. A lot of guys have this misconception that if I take it and I put it into the docking station turned off like that, it takes longer. So they'll take it out of the charger, they'll turn it on, and then they'll stick it into the docking station. That actually is a little slower because what ends up happening is it actually has to go through and it has to turn the instrument off and then turn it back on in docking station mode so that it can run through what it needs to do. So you're better off if you're looking for speed, just to take it out of the charger, stick it right in, and there you go. Now, right here, it's going through, it says reading settings, updating instrument settings, and it's doing all that maintenance for me. I don't have to do anything because it's following along with what I told it to do inside of my software. Now, going through downloading alarm events, downloading data log, and now it's done. Now, you'll notice I have a green and yellow light. Green and yellow says, hey, I'm done doing what I need to do, and I'm just charging, because the docking station will act as a charger as well. Whenever it's fully charged, the yellow light will go off, and the green light will stay on. At this point, you can take the instrument out, and we can go ahead and use it. So what I'm going to do is we're going to adjust here, and we're going to take a look at the instrument itself. All right, let me get a little bit more light in here again. All right, so on the instrument, you'll see up here at the top, you have your pump inlet, and underneath this cap is a small filter, okay? Never, ever, 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 ever run the instrument without this filter, okay? This filter right here is your filter of last resort, all right? Basically what I mean by that is this is there to stop whatever's getting into the instrument, but this is not your primary filter. So if you're doing like a confined space sniff before you go down into like a manhole or any type of confined space, make sure that on your tubing that you have on the instrument, on the end of the tubing, you have another filter. And when I say the end of the tubing, I mean the end that you're putting down into the hole, not the end that goes on to the cap. All right. Okay. So as we take a look here, we have our whole pump assembly up here, and then we have our instrument down here. Basically, if you remember from earlier whenever I showed this to you, here you go. This is the diffusion instrument. It's identical, except for this has just a slightly bigger battery in it because it's running both the pump and the instrument, and it's got this whole assembly at the top for the pump. Okay, if you were to actually open this up, you would just see one of these sitting in here. All right, so as we come down, all these little cutouts, they're all here for lights, okay? Just LEDs so you can see what's going on with the instrument. These ones right here are blue, these ones are red, and then right here in the center, we have a panic button, okay? Now that panic button, it's just like the panic button on your PASS device. You know, you press and hold that to activate it. Same thing here. You press and hold this for 3 seconds when the instrument is turned on, and it will activate a panic alarm, and it'll just start screaming and, you know, calling for help. Then we have our display, and then we have our two buttons down at the bottom. Now, these two buttons down at the bottom, we have our power button over here on the left-hand side, and on the right-hand side, we have our enter button. Okay, in between them, you'll see that little Gore-Tex membrane. That's because that's your speaker. And we keep that covering on there to keep dust, dirt, and debris from getting down into that speaker. All right, down here on the very bottom, this is where we have our charging connections. And then in this blackish part right here, you'll see a purplish window. That is the infrared data port. That's how it actually communicates with the docking station. The docking station has a corresponding port in the same area, and what it is it's infrared. So it's like the old television remotes where if you were standing in front of somebody and you were clicking the remote, it wouldn't change anything. Now they're all basically Bluetooth or wireless of some sort, but the older ones with the little light bulbs it had on the end, that's the same thing. It's communication, it's wireless, but it's using light. So again, if the instrument gets really extremely dirty, you might get a communication error on the docking station. If you do get a communication error, just come, wipe that off right there. There you go. Okay. If you ever get any charging errors, make sure you clean off the contacts. They are gold plated, so be careful. You don't want to, clean with anything too heavy or like astringent wise or anything like that. Our actual recommendation on cleaning those is one of these, a pink pencil eraser. Okay, the pink ones. The ones that are on the end of your standard, like number 2 pencils, or if you can get the little wedge ones, those ones work best because you can get them in there. But what you can do is you take that and you rub that onto the gold contacts, and that will clean off the gold very well because this has enough abrasive material in it that it causes enough friction to clean it without damaging the gold contacts. On the back of the unit, you have all your approval labels, serial number of the pump, okay? On the side of the unit, on the left-hand side, you will find a barcode, and on the right-hand side, you will actually find a serial number. Now, that barcode on the other side corresponds with this serial number right here. Focus. It's a little too small. It doesn't want to focus in on it. But anyways, that serial number is the serial number of the instrument. Whenever you call in and say, hey, I need some tech support help or I got a question on this instrument, this is going to be the serial number you give us. Do not give us this serial number right here because it doesn't get tracked the same way. This is the one that we're looking for right here on the side. Now, you might be saying, wait a second, we're firemen, we're rough and tough, and that sticker is going to get worn off, after, 2 months or something. How do we get that serial number if we need it? Well, on the instrument, there's a way to actually get what's called the quick access screen. And what you do is you press and hold both buttons together, and it will come up, and on the display, it will show you how much battery life it has, what sensors are installed, and at the very bottom, it shows you the serial number. This is how you can get to see, what's going on with your instrument without having to fully turn it on. So like I said, you just press and hold both buttons together. Comes up with the quick access screen, shows me my sensors that are installed, and my battery life. Okay, this one needs charged. All right, so that's your basic overview of the instrument. Let's talk about using it. All right, so you need to use the instrument. To turn it on, you just press and hold the power button, which is your left-hand button. Instrument will come on, goes through, starts up with the screens. You'll hear the pump kick on, and you can actually program it with welcome messages like mine says, work safe, be safe. You can program it to say anything you want right there. Some fire companies around me, they've got these same instruments. So what we've done is whenever it fires up, like mine says station 61, the next town over is Chippewa, and they have these as well, and theirs says station 22. That way, then we can see if somebody mixes them up, we turn them on, and it comes up and says, oh, that one's ours. So I just say OK by pressing the enter button. Excuse me. And then what you have to do is you have to do a pump test. This is different. This is not a bump test. This is the pump test. To do the pump test, just take your finger, stick it over the pump inlet. It will kind of stall out the pump. The pump may stop completely. It may not. Okay, it all depends on the flow of the pump. Whenever it's done, it will come up and it says press triangle. Well, that's because it's telling you to press the panic button. On it, just give it a quick press. Don't press and hold. If you press and hold, it doesn't acknowledge it. Now, if you don't do the pump test, the instrument will not continue with startup. And then it will just continue running through all of its startup displays, showing you date of last calibration, showing you current date and time, all of the FCC IDs and everything else. Because, these things, they do have wireless capabilities built into them for communication in between instrument to instrument and device to device. So, if you ever do upgrade to any of that kind of stuff, it does have all those wireless features in there. And does take a couple more seconds here because then it goes through and it shows us each sensor. And whenever it shows us each sensor, it's going to show us all the settings for each sensor. So like right here, here's my O2 sensor with its low alarm, high alarm, then LEL, low alarm, high alarm. Then it will go through and do H2S, low alarm, high alarm, STEL, TWA, and then it will do the same thing for CO. Yours will actually give you one more since you do have HCN in your instrument. I don't have HCN installed in this one. All right, so now we're at our real-time display. Okay, so this is where it becomes very vital to remembering a couple of things. Whenever you turn the instrument on, okay, we know press and hold the power button, it comes on, we do the pump check. Okay, that's a no-brainer. Well, there's a couple other steps that we have to do. After you turn it on, you have to do what's called zeroing of the instrument. And zeroing of the instrument is in a fresh air environment, you make sure that you go to the zeroing screen. I'll show you how to do that in a second. And you hit the enter button, and it then does a zeroing. It establishes the baseline for the sensors. Why this is important is because, as I said earlier, calibrations are done once a month. Okay, and with the calibrations being done once a month, sensors, they'll drift. Okay, they drift a little bit positive, a little bit negative. It's inherent of sensors. There's nothing that you can do about it. And that's why some people are like, well, should we calibrate more often? It doesn't solve that. It still will do the sensor drifts. So that's why we have the zeroing. Now with the zeroing, okay, again, it is done in a fresh air environment. So you make sure that you are not standing behind the running vehicle, right next to the exhaust coming out of the cab, anything like that. You want to make sure it's away from everything else when you do that. All right, so let's go over a couple things, and I'll show you how you do that zeroing. So first, let me get the backlight back on. Okay, you can see all your sensors and what their units of measurement are. Up here at the top, you see the little fan. That's telling me that I have a pump and that it's running. Next to it, I've got the little antenna with the number 0 next to it. That's that wireless. It's telling me right now I don't have anybody connected to me. And then in the top left-hand corner, I have a check mark. The check mark means that it is checking for gas. In the top right-hand corner, you'll see it's flashing between battery, time, and temperature. Okay, so the time is the current time. The battery is my battery life. And then also the temperature is internal temperature of the instrument. It's not ambient air temperature. Okay, so remember that. That's there so that whenever we have people that are doing readings in extremely cold and extremely hot environments, that they know, hey, it's still within its measuring range for that. Now, as for the battery symbol, okay, let's get that back up on there, and you'll see it's going to come up with the battery. And you're going to see that the battery has 3 bars, okay? Now, right now, I'm down to 1 bar. That does not mean that my battery is going to die right this second. No. Each one of those bars is equal to 25% of the battery. And then the final battery symbol itself, whenever it's empty, is 25% of the battery. So what that means is whenever you have a completely empty battery symbol, you still have about a quarter of your battery remaining. Whenever the battery is completely dead or it's starting to die, on the screen, it'll come up with a big battery symbol with a line through it. And then it's going to be beeping and flashing at you, letting you know, hey, I'm going to die. You know, you got about 20 minutes of runtime when that happens. And that's whenever you know, hey, we need to get that changed out. All right, so to navigate through, I'm going to click the power button, which is my left-hand power button. And first screen is my lens wireless. Next screen is how many days since calibration. And then the next screen is my zeroing function, the big 0 at the line through it. This is what I was talking about. So after you turn the instrument on, you're going to want to come here. You hit the enter button, and that starts the zeroing process. During the zeroing process, you're going to see it's going to go back and forth because it's doing that. And then at the same time, on the O2 sensor, it's going to give you a kind of a high number. That's because every time you zero an industrial scientific instrument that has an O2 sensor in it, it actually calibrates the O2 sensor because it's calibrating it to ambient air. You'll get the check marks on it, and then you can just wait because it beeped, it flashed, it vibrated, so then you know it's ready to go. You just wait a few seconds, it'll time out and go back to the real-time display. Now, if it's set up in the default settings, what you're going to see next on there is it will actually come up with a little bottle on the screen with a C in it, and that's because it's looking for calibration gas. If you hit the enter button, that will allow you to calibrate the unit manually. And I'll show you here in a second how you can disable that in the settings of the instrument online. With that, you can make this instrument extremely simple. You can have it turn on. You can have just the main display. You can have it show just zeroing and just the peaks, and that's it. So you can configure this however you guys want. I have mine configured that way for the fire department, so it's simple. All right, so there's my zeroing again. As I click through again, there's my bump if I need to do a manual bump test. Then here's my peaks, okay? So up here at the top, you'll see the little mountains with the arrow pointing towards the peak of the mountain. This shows me the highest reading of all gases I've seen except for oxygen. It shows me the lowest. To clear it, I just press the enter button where it says clear, and it will clear it out, okay? Now, obviously, I don't have anything on any of my other sensors right now because there's no gas in here. So that's the reason why the only thing it changed was O2. Took it back to whatever the current reading of O2 was. If I keep clicking through, it's going to show me my TWA, my time-weighted averages, and also my STELs. And then, one more time, back to my real-time display. So does anyone have any questions about the basic operation of the unit right there?
So the TWA, I know that's like a day's worth. How many hours is that?
So TWA was actually based off of an 8-hour exposure by default. Now, what you can do with that is you can change that to, whatever you want, depending on what you're using it for. Now, these instruments that you got them for, are they basically going to be overhaul instruments and CO alarms?
Mostly, yes.
Okay. So my recommendation on that would be to actually, and I'll show you in the settings, probably to go in and actually take and shut off the TWA. To shut it off, though, you actually have to just crank it up as high as it will possibly go. The reason being is CO calls and overhaul, the whole purpose is you're still wearing your SCBA until the levels come down low enough that you can, take it off. So that's the reason why TWAs, they really don't matter, because all those readings that you're getting where it's in the high levels, you're still under air. So, I'll show you how to do that, or how you can also just change the time frame. And that's going to be up to you guys on how you want to operate with that. You can discuss it among your chiefs or your safety officers or whoever's in charge of helping you with all that. But that's just my recommendation on something like that, because, like I said, it's just TWAs, they don't really make a lot of sense in the fire industry on an instrument like this. Now, if you're using our little single gas like CO meters on your house bags, those ones, definitely have the TWAs turned on, because then, that's giving you that exposure all the time whenever you're going into people's houses and everything else.
Now the unit came with extra tubing. Is that to, if we need to go down a manhole or something to test the air?
Correct. That is for confined space sniffing, and that will just connect on to the inlet up here. And then with that, you do have to do a little bit of math, okay? And that was the next thing I was going to talk about with these instruments, is when you're using the instruments, okay, with no tubing on here, okay, say you're taking a reading, here's the thing. There's a lot of guys that still think that these things are instantaneous readers. As much as I wish that they were, they're not. Okay? So with that, what you have to do is you have to do a little bit of waiting. So like if I'm doing like a CO check around a house and I'm checking around the furnace, I'm going to stop and I'm going to wait at least 30 seconds. If in 30 seconds around that heat exchanger, I'm not getting any discernible readings on the CO sensor, I'm going to just say, okay, let's move on to the next spot. If in that 30 seconds time I do, I'm going to stop and I'm going to wait 90 seconds, because in order to get a full 100% reading with the electrochemical sensors in here, you actually have to wait 2 minutes, okay? Now with the tubing on there, you have to wait for it to draw through the tubing. So in the box, it came with a little extra piece of tubing, should be about 10 feet. So that would mean that you would wait 2 seconds per foot plus the 2 minutes. So in order to do that test, from the very bottom of the tubing to the instrument, that right there is 20 seconds plus your 2 minutes. So you're waiting 2 minutes and 20 seconds when you're doing your confined space sniffs. Does anybody have any questions about that with the meter reading and also the confined space tubing?